Hi everybody, thanks for being here. It's John Pushkar. Today is episode 4, the final episode, items 15 through 20 of my 20 real-life fired equipment and mechanical systems hazards presentation. So sit back, relax, remember, take good notes, email me if you have any questions. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. I want to next talk about things you could look for with the naked eye while you're strolling through your facility next time. I want you to start looking up periodically in a safe manner, and I want you to start thinking about pipe hangers and the way pipes are supported. You see, for example, here, this is a spring hanger. And if that spring is not compressed at all, and in fact, if you look up and you could see that there's actually no engagement of the hanger with the pipe, that means the spring hanger is not carrying any load. That means that other hangers in the system are carrying more than their design load. I want you to also be aware of if there appear to be signs of obvious pipe movement, like you see here. Sometimes that's a result of piping systems that are not experiencing the proper expansion or contraction, where maybe expansion joints have failed. Sometimes it's also a characteristic of water hammer that's occurring. In any case, if you see a lot of movement, or maybe pipe slides that are barely engaged, or pipes that are now off of their supports, you need to report that immediately and it needs to be investigated. You might also have hangers that are missing. You see, where you have hangers that are missing, or you have hangers that are not loaded properly, it means the pipe is deflected. You won't see it with the naked eye, but if you put a laser beam up there, you might see thousandths of an inch of pipe sag between hangers. And when this happens at a flanged connection, we get uneven clamping force of the gasket, and it invites leaks. And leaks of gaskets, especially in high-pressure systems, very bad thing. You're inviting that gasket to blow out and there to be a severe leak that can hurt somebody or take your facility down for days. I'd like you to pay particular attention to whether or not your actual natural gas valves can be shut off. Imagine the position you would be put in if a pipe were to get broken somewhere or there to be some emergency with a piece of fired equipment. Look to the left of my picture. Do you see how long that handle is? It's even bent. Do you think that valve's easy to move? Look to the middle. You see the corrosion around what's called a button head fitting? That's where special sealant gets injected to make this valve function properly. And look to the picture in your extreme right. Do you see how many times that's been painted over? I doubt you can get that valve to move. You see, I'd like to make you aware of what is the most prolific type and style of valve installed in natural gas systems. And this is called a lubricated plug valve. Here's a cutaway of one such valve. And if you look down, you'll see that there's a plug, there's a body, and as we rise toward the top of the photo, you'll see a sealant injection fitting. The plug and the body are not in intimate contact with each other. In fact, there's an air gap there. And it's only the injection of a very special sealant material that gets between the plug and the body and makes this valve function. Besides making the valve function, it also protects you from corroding the plug to the body, which makes these things seize in position and be not functional. Have you ever seen a sealant injection gun like this at your facility? If not, you've got a problem. It takes a special device like this, which injects a very special material, a valve sealant material, at thousands of pounds of pressure down into the valve body and seat area. There's a special injection process you have to use, and you have to be trained in how to watch a gauge to know when you've put enough in or it doesn't have enough, and it's something that needs to be done carefully. NFPA 86 is standard for ovens and furnaces. Well, it says that this style of valve needs to be refreshed on an annual basis. And likewise, most of the valve manufacturers, they'll tell you the same thing. And oh yeah, let's now talk about this valve handle position and what the hazard could be here. This is a lubricated plug valve, and like many lubricated plug valves, it's installed with a handle that can be removed and replaced in any position. So if you look below my picture, many people would immediately look at this and intuitively think this valve is closed because the handle is at a 90-degree position to the pipe itself. But I want to let you in on a little secret. Most valve manufacturers, if you look to the right of my picture, well, they have little raised bumps or some other nomenclature that allows you to understand, even if the valve handle's removed, whether this valve is open or closed. In this case, those two raised bumps, well, they're in alignment with the hole that's in the plug. So this would actually mean that this valve is open. Now look below my picture again. Look very carefully. Do you see the tragic event that could happen here? Even though this handle has been installed perpendicular to the piping system, look at the two little raised bumps. Indeed, this valve is actually open, and this could make for a terrible tragedy for someone working downstream thinking that this gas is shut off. In case you couldn't see it very well in the last photo, here's an enlargement showing you again the position of those two bumps on this valve and the position of the handle. And just how bad could it get? Well, unfortunately, not too many years ago, this exact scenario played out at the Minnehaha School outside of Minneapolis, where a gas company contractor thought that a valve was closed. It was actually opened. When he started to disassemble things downstream, the pressure was overwhelming. He couldn't get the gas shut off. 2 folks were killed. There were 9 injuries and millions of dollars in damage. You can find this for yourself by searching the National Transportation Safety Board website. There's an extensive, very informative report about this. I want you to also understand, moving forward, there's no such thing as a small gas leak. As a gas leak that, well, it's okay. Because one of the things we don't know is when things are going to continue to deteriorate and a very small gas leak is going to turn into a very large gas leak. And gas leaks can be a problem inside a building, outside a building, and even if they're underground. Remember, the lower flammable limit of natural gas is only 4.3% by volume in air. If you take the inverse of that, it means 1 cubic foot of gas can make for a 23 cubic foot flammable mixture. So even a small gas leak that accumulates in a room over time can become a flammable mixture and be immediately ignitable. So where do you need to look? This is a brand new valve, a brand new 8-inch valve that was installed, and it even had a leak, so you can't trust new components. You can't even trust welds. You need to also look at flanged connections. Lots of people wrap duct tape around flanges, poke a little hole in them, and check that with a soap solution or a combustibles indicator. Also, check threaded joints very carefully. And if you've got an underground piping system somewhere on your facility, you especially need to be aware of its corrosion protection system. Most underground gas piping systems, well, they're protected with sacrificial anode cathodic protection systems. The Prescient Technical Services online school has a video that talks about how this works. But if you've got a little test station like I'm showing you on the right of my photo, and you have no idea what that's there for on your facility, you need to get a hold of a qualified corrosion protection engineer who needs to come take some readings to understand if your system is still intact and still providing any protection for your underground piping. One of our auto plant clients, people were smelling gas in a parking lot. The gas utility came, shut down the system. When they started to dig and explore, they found more than 200 feet was like Swiss cheese and ready to fail catastrophically. They were down for 2 weeks to get this system all repaired. Could your facility afford to be down for 2 weeks if the same sort of circumstances were identified? Something to think about. And if you do happen to have leaks and need to do repairs, remember, There are very special processes for doing gas piping repairs safely. It's not like doing a water pipe repair or a steam pipe repair. There's actually 6 steps which I've identified here, which we're going to go through. How bad can it get? What can go wrong? You need look no further than the incident that occurred at the ConAgra Garner, North Carolina facility in 2009. There was a man who installed a brand new hot water heater, and there was new gas piping put into service. He released gas into the building over a number of hours because he couldn't get the burner lit. Suddenly, there was a catastrophic explosion that killed 6 people and destroyed a large part of that facility. Today, that facility and its 900 employees, well, they're gone. It's just a big field right now. The 6 steps for doing safe gas piping work are doing proper shutoffs and isolation, depressurizing the piping system and then doing a proper purge using nitrogen. You have to make the repair. Then you have to do a pressure test or a leak check. You have to purge the air out of the system before you bring gas in. You want to bring gas into a pipe that's got nitrogen in it, not air. And then you have to very carefully reintroduce natural gas to the piping system in a way that gives you the proper concentration at the equipment that you're trying to light. I don't expect you to understand all of this just from hearing the 6 steps. It takes extensive training and processes, including purge procedures. You see, just the fact that you're using nitrogen to get rid of the gas and render the piping system safe means that you're dealing with another hazardous substance, nitrogen. Although it's 78% of every breath we take, 1 breath of pure nitrogen can kill you instantly. This purging process, it also takes special equipment and meters so that you understand when the piping system is in a condition to be worked on. You can get more information about this in the National Fuel Gas Code and in NFPA 56. You can view both of these documents for free at www.nfpa.org. And last but not least, you need to have a high hazard job protocol. You can't just relax because, hey, a contractor showed up. He's got a white Econoline van and they seem to have cool graphics on it. And their tech really seems to know what he's doing. No, in fact, it's the opposite. Because most incidents that I've been part of have occurred while somebody's been working on something or servicing something. I had 43 people in my employ. They weren't all Einsteins. Everybody's got A players, B players, and C players. Do you know who they sent you, what their qualifications are, how much experience they have doing exactly what you need done today? Here's an example of just how bad things can get. This is the University of Nevada, Reno dormitory, the Argenta Hall facility. A couple of years ago, they had a horrendous gas explosion. By the grace of God, no one was killed. It's an 8-story dormitory, and after a contractor misjudged how a particular valve was supposed to work, tried to light the boiler, there was a horrendous explosion of that boiler. It broke the gas piping, released lots of gas into the room. He ran out. People couldn't get the gas shut off. It went up an elevator shaft, made for a second horrendous explosion. You could see some of the damage here. Now, folks, if you want to learn more about this incident, the State of Nevada Fire Marshal's website has tons of documentation about this, just wonderful information. I'm very appreciative it's there. But I'm here to tell you, this isn't the only incident of this sort. Actually, the picture to my left is the same style of gas valve where a contractor servicing one of our auto clients in 2008 did virtually the same thing, blew up a boiler, broke the gas line, but there happened to be a maintenance person there who had the presence of mind to know where to shut off the gas immediately and did so. You can't always count on that. What I want to do is get you to have a procedure so the odds of dealing with and mitigating things that might happen, well, you actually reduce the risks and they somewhat get to be in your favor. I didn't invent this hazardous job meeting process. In fact, I learned about a practice like this that U.S. Steel, one of our clients, was doing years ago. They had their own criteria for what constituted a hazardous job. But once they defined a project that met those criteria, it launched a whole set of checklists and meetings and walkthroughs that were very valuable. You need to decide for yourself what the criteria is going to be. Maybe it's high voltage switchgear service. Maybe it's gas piping projects, boilers, steam piping. Maybe it's crane lifts. But create your own checklist type system. What are the qualifications and experience of the person that was sent or the contractor, or what do they need to be? Is there a job-specific safety plan? What gas shutoffs would be used? Who would use them? Are there handles on the valves? Are the shutoffs marked? And all of these processes typically always include some type of site walkdown and review of conditions. I hope you've gotten something useful out of these episodes. If you have any questions, please contact me, www.prescientts.com, or you can call me direct on my cell at 216-213-6201. Thank you very much, folks, for participating in these episodes. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.